Hello everybody and welcome back to the next section of Pre-Calc 11 notes. We are going to continue on with solving quadratic equations. In the last video we talked about how you can do that with graphing and even factoring, but we saw that sometimes factoring wouldn't actually work. We weren't able to factor some of our equations, and so we were sort of hit a dead end. We're going to learn a new trick today that's going to help get us past that. So just as a kind of comparison, we're gonna solve this equation first by factoring and then by completing the square. And so we should have already seen from last unit the how we can complete the square. We can use that to actually solve these equations. So as an example, we'll solve x squared minus 4x minus 5 equal to 0. And if we want to do that by factoring, again, we're finding two numbers that multiply to -5, but that add to -4. And those two numbers, yes, you guessed it, are -5 and +1. And so we can factor this into x minus 5, x plus 1 equals 0. And then if I set each of these binomials equal to 0, and then if I set each of these binomials equal to 0, I can solve for x. So x can equal 5, or if I do this one here, x plus 1 is equal to 0, that means x can equal -1. So x can equal -1 and 5. Those are the solutions to that equation. So how do we do that if we do that by completing the square? You'll remember for completing the square, I'm going to start with my exact same equation here. When we complete the square, we're just going to look at just these first two terms. We're going to kind of separate them out. We're going to leave the c term kind of off on its own there. And what we're going to look for is what could we add in here? X squared minus 4x. Or yeah, what could I add there that would make this a perfect square? You recall that it's going to be half of this number squared is what's going to make the perfect square. So half of -4 is -2. That number squared is 4. So I'm going to add a 4 there. Of course, on the outside of my brackets, I still have a -5 because it was there before. And I need to also factor in, I can't just come along and add 4 to an equation and have everything be okay. I need to also subtract 4 on the outside here to make up for that. And that is going to equal 0. So this can now be written as a perfect square, which is x minus 2 squared minus 9, and that equals 0. And this is basically that vertex form of the functions that we saw before, okay? But how can we keep going to solve for x? Well, if I want to solve this for x, I can do that, but first I need to I need to move that 9. So I'm going to add 9 to both sides of the equation, and I end up with x minus 2 squared is equal to 9. I want to solve for this x, but it's kind of locked away in this bracket, which is being squared. So what I'm going to do is I'm going to square root both sides of that equation. And when I do that, that's going to eliminate the squared, and this is just going to become x minus 2 equals. Now, if I was to ask you what is the square root of 9, and you were to say 3, you would be exactly half right. Because while +3 squared is 9, so is -3 squared. And so whenever we take the square root, we have to remember that our answer is going to be plus or minus of that number. So the answer here really is plus or minus 3. And we're going to keep going here and see where this goes. So now I want to move the 2 over to the other side. I'm going to add 2 to this side, and I get x is going to be equal to 2 plus or minus 3. Now that's a really weird way to write things. But let's think about what that would actually mean. If the answer is it's either 2 plus 3 or it's 2 minus 3. Those are my two possible solutions. Well, 2 plus 3 is 5 and 2 minus 3 is -1, and you can see that's the exact same answers that we got by factoring. So again, x can equal -1 and 5, and those are my solutions. So the process, to summarize, if we're going to solve by completing the square, first of all, when should we use it? Well, if we're already in vertex form, like you can see this one right here, I'm already in vertex form, well, that's just going to be easier. Just go ahead and finish it off that way. But the other time is if it cannot be easily factored. Often we have roots that aren't nice whole round numbers. Most of the time, that's how functions work out. And so if you get that case, you don't have to factor it. You can go ahead and complete the square and solve. The steps are kind of here as follows. So you're going to complete the square. You're then going to isolate the squared term, take the square root of both sides. Don't forget this. This is the easiest thing to forget, that you want to keep both the positive and negative roots, because that's going to give us our two different answers. And then the last point here just says discard extraneous roots. If we ever have a problem where we're looking for an actual solution, it's sometimes possible that both roots aren't reasonable answers, okay? If we're just solving an equation that's not attached to any meaning, well, then we might get two answers and that's fine. But if we're solving an actual real world problem, you might look at this and say, well, that answer doesn't make sense. So you can always think about that. Last thing I'll mention is we want to get in the habit of converting to mixed radical form. And if you don't remember how that works, we're going to talk a lot about radicals in a future unit, and so you'll be a little more comfortable with it there. But basically the idea is if you can simplify your radical, you want to do so. And an example of that is the square root of 8 can be written as 2 root 2. As I said, we'll talk more about radicals moving ahead. Okay, so let's take a look at these examples. This first one is just straight up way easier. If I move the 8 to the other side, x plus 2 squared equals 8. Take the square root of both sides, and I get x plus 2 is equal to plus or minus root 8. And then I'm going to move the 2 to the other side by subtracting, and I get x is equal to negative 2 plus or minus the square root of 8. As we mentioned, this square root 8 can be simplified and written as 2 times the square root of 2. Okay, so let's look at this next one here. I've got x squared plus 4x minus 8. I can't think easily of any factors that are going to multiply to negative 8 that are going to add to positive 4. So since I can't factor it, I'm going to go ahead and I'm just going to complete the square on this term here. So I've got x squared plus 4x. And I would need to add here half of that number squared. Half is 2, squared again is 4. So I'm going to add 4 there. I have my minus 8 on the outside. I'm going to subtract 4 to make up for the fact that I added 4, and that whole thing is equal to 0. I can then set this as x plus 2 squared minus 12 equals 0. Move the 12 to the other side. X plus 2 squared equals 12. Take the square root of everything, and I get x plus 2 is equal to plus or minus the square root of 12. Last but not least, I need to move that 2 to the other side of the equation, and so I get x is equal to negative 2 plus or minus the square root of 12. As I said, we haven't really covered radicals yet, so if you were to leave your answer like that, that's okay for now. But what we'll learn later on is that this can actually be simplified and written as plus or minus 2 root 3. And I'm not going to get into that right now in this video. We'll save that for later. I should point out, right, that either of these answers, whichever form you put it in, this is two answers, right? It's both negative 2 plus root 12 and negative 2 minus root 12. You could punch both of those numbers into your calculator, right? You could just actually type in negative 2 plus the square root of 12 and negative 2 minus the square root of 12, and it would spit out some irrational number that goes on forever, potentially. For now, we're just going to leave it like this. That's simpler than writing out all those decimals, okay? Okay, let's look at this. Let's look at this last example. So I'm going to bring the 5 over to the other side of the equation and rewrite this as 2x squared minus 8x minus 5 is equal to 0. I'm going to complete the square, and again, I'm just going to look at these terms, the ax squared and the bx term. I'm going to factor that first, so I get take out the factor of 2, x squared minus 4x. And what will I need to add here? Well, half that number is 2, as negative 2, squared is positive 4. And then I've got a minus 5 on the outside. Be careful here. When I added this 4, right, adding this 4 inside the bracket was really like adding 2 times 4. So outside of the bracket, I need to subtract 8. And that whole thing, of course, is still equal to 0. So now I have 2 times x minus 2 squared. I'm just rewriting that in the perfect square form. Minus 5 minus 8 is going to be minus 13. And that equals 0. I'm going to move 13 to the other side of the equation. Maybe I'll do that over here. So I get 2x minus 2 squared is equal to 13. Divide by 2. And I get x minus 2 squared is equal to 13 over 2. Take the square root of everything. X minus 2 is equal to plus or minus the square root of 13 over 2. And I know this is looking ugly, but we're finally there. I move the 2 to the other side, and I get x is equal to 2 plus or minus the square root of 13 over 2. And again, that's the simplest way to leave that answer. I could write it as 2 plus root 13 over 2 and 2 minus root 13 over 2. That's just more work, so I'm going to leave it there. Okay, so let's look at one word problem. We'll do this first one here together, where we can apply this. We've got a widescreen television which has a diagonal measure of 42 inches. This problem must have been from the 90s because the 42-inch television is a widescreen. That doesn't matter. So the width of the screen is 18 inches more than the height. Determine the dimensions of the screen to the nearest tenth of an inch. Okay, again, with these word problems, now these can be very challenging, and the biggest part of it is setting it up. If you've practiced the skill of completing the square and factoring all that stuff, that's great, but you can't put that into practice if you can't set up the problem. And so I'll say it time and again, the first thing you have to do, you absolutely have to start with a picture. And so luckily I'm an expert artist, and so this beautiful picture here is a widescreen television. You're welcome. So what do we know? The diagonal measure here, that distance across is 42 inches. 42 inches. And so then the width of the screen, so the width here, I'll call that W, is 16 inches more than the length. So if this is the length here, or the height, or however you want to think of it, so if we need to come up with some way of relating this that has only one variable in it. So there's different formulas we might use, but we have to put it all in terms of the same formula, or the same variable, and that's the tricky part. So if I call the height of this TV screen x, for example, then I need to come up with a variable to describe the width, or an expression I should say, that uses only the variable x. I can't call this x and that w because those are two variables and I'm stuck. But if I think about what this means, the screen is 18 inches more than the height, or the length, then I could think if this is x, then this side here must be x plus 16. And now I've got an expression here that I can relate to the other. So it's determining the dimensions of the screen. So basically we want to find what x is. Once we know x, we've got this whole thing figured out. And what do I know? Well, I know the side, these two sides are x and these two sides are x plus 16. And now we have to start to think about what equations can we use that apply to this situation right here. Like, for example, I know the area of this rectangle would be the length times the width, but I don't know anything about the area, so that's not really going to help me here. What I do know is I know the diagonal of the TV is 42 inches across. And what you might recognize from the picture is that if the diagonal is 42 inches across, then this right here, including this diagonal, well, that is a right angle triangle. And there is a formula I know about right angle triangles, which is a squared plus b squared equals c squared. And so this is going to actually allow me to relate the diagonal and the two sides to each other in a way that will help me solve for one of the sides. Let's say I call a this side here, so this becomes x squared plus x plus 16 squared, so that's a and that's b, is going to equal 42 squared. Well, this, I can see already, this is going to turn into a quadratic equation where I'm going to have an equation with a degree of 2. I'm going to need to collect all the like terms. I need to bring everything together. So let's see here. Let's expand this out. This is x squared plus x squared, and then I'm going to get plus 16x and another 16x, so I'm going to get 32x, and then plus 16 squared. Off the top of my head, I don't know what that is, but my trusty calculator tells me I should have known it was 256. And that is equal to 42 squared, and I definitely don't know what that is. But again, my calculator tells me that's 1,764. So you can see now, if we just collect all the like terms, then we're going to have a quadratic. So this is, I'm going to subtract 1764 from both sides here. And I'm going to collect my x squareds, and I'm going to get 2x squared plus 32x minus, and that number minus 256 is going to be 1508 equals 0. Okay, so I'm on my way, and now I could complete the square, but before I do that, just to make my life a little bit easier, I can see there's going to be a common factor of 2 here. So I'm just going to divide both sides of the equation by 2, and I get x squared plus 16x minus 1508 divided by 2 is going to be 754 equals 0. And from here now I'm going to complete the square and see where I end up. Okay, so I'm just going to do this next part over here. So I've got x squared plus 16x plus something. And on the outside of the bracket, I've got minus 754. And so I'm going to have to add in here half of that number squared. So half of 16 is 8, squared is 64. And so I'm going to subtract 64 on the outside. And this whole thing is still equal to 0. So this perfect square becomes x plus 8 squared. And then I've got minus 754 minus 64, which is going to be minus 818 equals 0. And now I can just kind of follow my steps and solve. So I'll move 18 to the other side. I've got x plus 8 squared equals 818. Take the square root of both sides, and I get x plus 8 equals the square root of 818. Okay, so the square root of 818 is 28.6. We're going to go to the nearest tenth, so 28.6. So this is plus or minus 28.6. And then I just need to move 8 to the other side, so I get x is equal to negative 8 plus or minus 28.6. So what does this all mean? Well, there's two possible answers here. There's two results. It's either x is either equal to negative 8 plus 28.6, or it's equal to negative 8 minus 28.6. And so what are those two things equal? Well, 8 plus 28.6, negative 8 plus 28.6 is going to be 20.6 inches. And negative 8 minus 28.6 is going to be negative 36.6 inches. Now, this is the point where you look at this and say, okay, I've got two answers for x. But if we stop and think about it, I mean, I know I'm old-fashioned, but all the TVs I've ever seen have actual real-world positive dimensions. I can't imagine a TV that has a width of negative anything. I don't even know what that means. So this answer right here, while it did answer my question, doesn't make any sense. And so I'm going to reject that. I figured it out, I calculated it, but it just doesn't work. And so my value for x must be 20.6 inches. So x equals 20.6 inches. And that, of course, is the height. Just remember that we were looking for both of the dimensions. So I can go back as well and say, well, the width was just x plus 16, so that must equal 36.6 inches, and that is my width. So those are my two dimensions for that TV. All right, that's it for solving using completing the square.